Hi, my name's Dave. I don't usually make YouTube videos, I usually make video games, but I've been teaching a friend to program using Pico-8, and I thought, hey, I might as well make a little video, see if anybody else is interested. You can buy Pico-8 from lexalawful.com right here. I think it's super worth it, but if you just want to kind of test drive it or whatever, you can go to pico-8-edu.com and it'll run right in your browser. It's a little limited, but it's pretty cool. And it's a great way to get started. All right. So I'm just going to assume you don't really know programming stuff. Maybe you like games. You're interested in it. Let's get started. All right. So this interface, it's kind of like a command line interface where you can like type stuff into it. This is how computers used to work. There's more to it than this, but let's just take a second and look at this. All right. So you can type stuff into it and you can say like, hi, and it says error, it doesn't know what you're talking about because you don't talk to it like a human being. You talk to it like a computer. And you kind of got to know its language. So what is its language? Here's a command. Let's get all this stuff off the screen. Let's say CLS, which stands for clear last screen. And it understood that. It said, all right, let's get rid of all this stuff. All right. How do we know these commands? Well, I've got this cheat sheet open. There's lots of stuff in here. But this is basically like everything you could ever want to know. And a lot of it, like, I don't even look at a lot of this stuff. And so like, here we go. Let's look at shapes, right? So we can sort of guess at what this stuff means, but we can also ask the computer. We can say help. And let's look at this. There's a function called circ. And it'll tell us, draw a circle at x, y with a radius of r. When a negative radius is given, nothing is drawn. All right, good to know. Okay, so we can just try this, and we won't clear anything. And just follow along with me here. Circ, and then parentheses, open parentheses, and it needs an x, a y, and an r. And so let's just type in 64, and 32. All right. We drew a circle right for us. There's a circ fill. We can do circ fill. And we'll draw this somewhere else. We'll do like 20, 20. Let's do 90 for our radius. And then you can see over here, there's like some of these things are in brackets. This is for color. Brackets means it's optional. So like it has a color that it assumed we wanted. If we want something else, we can give it another number. And there's a color palette. Don't worry about this second one here. This is a secret. This is obscure knowledge. There's 16 colors. They're numbered from 0 to 15, right? So this color, it looks like it was drawing in color 6. Maybe we want a green circle or a blue circle or a red circle, right? So red is 8. So we'll pass in the color 8. There's our big boy circle, right? And you can see it drew on top of everything else we did, right? And we can clear this screen, right? And if I want to like go back and edit a previous command, because I forget what it is now. What was it? You can press the up key and cycle back and forth, up and down through previous things. So let's make this smaller, right? Oh, that's much more manageable. Now see how it's just drawing everything over stuff that was already on the screen. And even now when I type, it's just drawing right over it. that is how everything works. That's how every program, every game, it's just layering drawings and clearing the screen and doing it again. Maybe a little different this time, right? Maybe just moving over a little this time, right? Clearing it and then moving over a little bit. Oops. Over and over and over. And it gives the illusion of animation. But everything is fake. It's a magic trick. It's just wiping the slate clean and layering new drawings on top of each other to make something that tricks you into thinking it makes sense. It's a lot of work typing it like this. It's not ideal. It's not how you want to make a game. So let me show you something. If you press the escape key, now we get our editor interface. And we can type code in here, all right? So we can type our circle or circ fill or whatever. Now notice when I start typing, it's gray as soon as it's something it recognizes from this cheat sheet, right? This circ, oh, it doesn't recognize it anymore. Oh, now it's green. It recognizes it, right? It's telling you, it's like, oh, I know what this is. This is one of the built-in functions. We could do oval, we could do rectangle, right? Let's stick with the circ. We're getting used to the circ. We'll put it at the middle of the screen, 6464. Now you'll notice this screen is like, it's old school, low resolution pixels. The Pico-8 screen size is 128 by 128, which seems like an arbitrary number. It's not. There's computer stuff that where it all makes sense, and maybe we'll get to that, but you'll get used to these numbers. So 128 by 128 pixels, 6464 is going to be right in the middle of it. We can decide the size of the circle, the radius. I can draw you a little picture here. If you imagine a point, right? This is the radius. It's the distance from the center to the outside of the circle, and then that's how the circle's drawn. So this is R, the radius. So let's just make our radius like 12 and our color 11. We'll make it green. Now we can hit Control R and it runs our little program. It just runs that little piece of code and it draws our green circle, right? We can change this to circ fill and it's a filled circle, right? But we're back in this command mode. It's not really like a game. It just runs it once and then we're done. Not the best. So what we can do. There's a function. All right, we've seen a function. This is a function. Circ fill. A function, it's a little hard to explain. It's a set of instructions that the computer follows. That's it. Okay, that was pretty easy to explain. But what does that mean? I sort of sometimes think of it as like a little machine, a little robot, a little robot in your computer, and you give it input. So like it expects a certain amount of input, 64, 64, 12, 11, or whatever. And then it follows its little instructions that are inside the function and it gives some kind of output. It does things and it gives an output. And so like the circ fill function, it takes this input, takes this data, and it gives us this output, right? And functions can do all sorts of things, and you can write your own functions, make your own little robots. Like this. Function. Now there's a built-in function here. Underscore update. And when you write a function like this, you gotta have these parentheses. And it's got to have an end to tell it the function is all the code inside here. And we put a tab for all the stuff in here to really make it readable. So you're like, oh, I see this block of code starts here, it ends here, and this is the stuff inside of it. All right? So we're saying, hey, Pico-8, you know your update function? The function that you run 60 frames per second, or 30 frames per second actually here. If we wanted to run 60, we can do update 60. 60 frames per second. I'm taking control of that. All right. And I'm doing stuff in it. Let's see if this works. You know, we don't know. Let's change the color. Let's change the color to 2. All right. Yeah, it's doing stuff. There was still like old stuff on the screen, right? If we change this to like 2, 6, 2, 4, whatever, just throw in random numbers here. Our old circle is still on the screen because we didn't clear the screen. So usually we want to do CLS, right? A, and now like not even the command line stuff is visible. This is like starting to look like the presentation that you want to see in a game. Now, there's this update function. There's also draw. Now, usually, I'm going to take this. I'm going to Control X to cut it, Control V to paste it. Usually, you want to keep pure logic stuff in your update, and then you want to put graphic stuff like drawing circles in the draw. And I kind of think about it like as game developers, we're like magicians. All right? Or like con artists, right? We're doing like 3-card Monty or whatever. We're doing a shell game. And we're lying all the time to the player to try and trick them into thinking cool stuff is happening. All right? But that means we have secrets. All the stuff behind the scenes. And the update is where we hide our secrets. It's behind the curtain, right? It's what's up our sleeves. It's the stuff we don't want them to see. And then the draw is the stuff we want them to see. That's the trick, right? And we'll get to how we use that. But that's sort of how I've been thinking about it. Now, sometimes you want to just like set up stuff at the beginning. And so there's one more built-in function you usually write. Init. Stands for initialize. Just get things started. Let's get this party started, all right? So those are like the 3 main functions in any program in Pico-8. All right, so we got our circle. Now it's not doing anything, which is boring. How do we liven things up? We want it to move around. Now, I talked a little bit about data, right? Computer program is really 3 main things. Input, data, instructions that the computer follows. How many things is that? What did I say before? Did I say 3? Who cares? This is sort of how I think about things, right? So there's like input, the buttons that the player presses, the stuff that they do. That sort of feeds into the data. You get data from the player. There's data in the program. And then there's instructions. There's what the computer does with that data. And then there's output. There's the stuff that the program gives back to the user. So like the graphics, basically, sound, whatever. And that's the magic trick, is making that seem like there's a world, right? There's an adventure. Okay. What good is all that? Data is what we want to focus on right now. We want to store it. We want to set it. We want to name it so that it's easy to work with, right? So we've got these numbers floating around here. What if I were to like pull these numbers out and give them names? So I can give that data any name we want. And we'll keep it real simple right now. We'll say x equals 64, y equals 64, r equals 12, c equals 7, right? And then we can just do x, y, r, c. Now what's going on here? It works, but what's going on? These are variables. They're little addresses in the computer's memory. And we're saying, hey, give me a little chunk of memory, put this number in it, and just for my convenience, just for me, the human being sitting here at the computer, I want to call it X. So that later I can say, hey, you remember that little bit of memory that I told you about? That we agreed we'd store the number 64 in there, and I called it X. You remember that? I want to use it. Bring it back. And so the computer says, yeah, I remember X. I got you. And it goes and it gets the number 64. All right, from its memory. And this is how we talk to the computer. So we're defining variables and setting values in them. All right? And then we can do stuff with them. In our update that runs 60 frames per second, every frame we can say, hey, remember X? I want you to change it. I want you to take the value that's already in X, and I want you to add 1 to it. All right? It's going to loop. It's going to do this every single time. So it's going to, at the start, say X is 64. Every frame it's going to say X. Oh, yeah, I remember X was 64 plus 1. Now it's 65. And then it's going to, right after the update, it's going to draw. And when it tries to remember X, it's going to be like, yeah, it's 65 now. And it's going to loop, and it's going to be like, now it's 66. Draw it at 66. Now it's 67. Draw it at 67. All right? The illusion of motion, folks. It's a trick. It's a trick because nothing's being really moved. There is no circle. All we're doing is painting the screen, repainting it, changing numbers, right? If I get rid of this clear, right, you can see if you don't clear it, the illusion kind of breaks down. All right, we can, here, let me show you. Let me show you this. You can even see, oh, wait, see less. All right, run it. Yeah. We can even do +2. CLS, run it. Yeah, see those spaces between there? The illusion totally breaks down. But what happens if we do clear the screen? It looks like it moves a lot faster, right? So this is sort of like the speed. All right, we could even be like speed equals 2. Right? Speed equals 0.1. Now it's really slow, right? We could do y equals y plus speed. And now it's moving on the x and the y. So you start to see how you can define variables and store stuff in them and use them in fun ways to make things happen, right? So we've got a cool animation, right? We've got our data, we've got our instructions, we've got our output, but what about input, right? Let's get rid of this. Behind the scenes, part of the magic trick. We're gonna listen to the player. Because a big part of video game programming, what have you, is listening and responding. We're going to say if. This is called a conditional. It's pretty straightforward. Logic. If btn, this is a function, see how it turned green? It stands for button. Parentheses. So what goes in this parentheses? Over here, controls, right? Button, we got button and button P. And then, oh, there's like numbers, right? So these numbers are like the codes for buttons. And we'll just focus on these arrows right now. So right is 1, left is 0. So it's like left, right, up, down. All right. So let's go over here. If button 0, that means we'll be moving to the left. Then. And see how we've indented, we've got this new block of code. And like something's going to happen here. You can write a little note to yourself in Lua with 2 dashes like this. All right, move left. That's just, this is not code. It won't run. It's just a little note to ourselves. What do we do if button 0? This is a function, right? You can tell because it's got these parentheses. This function takes in a control code, right? A number. And if that button is currently being held down, it will return true. If it's not down, it will return false. So if this is true, then it'll run this code in here. If it's false, then it won't run this code. So what do we want to do if the left button is held down? X equals X minus 1. All right? Or actually, X minus speed. We'll set speed to 2, whatever. If button 1, then move right. X equals X plus speed. All right, let's give that a test drive. Control R runs it. Now when I press left, hey, we're moving. All right. The illusion of movement. If button 2, then move up. If button 3, then move down. All right. Here's a little gotcha. It's a little weird the first time you do it. The direction for up is negative. Now the reason is we've got this screen. It's 128 by 128. The 0, 0 is this upper left-hand corner, right? And if you add to X, you go to the right. That sort of makes intuitive sense. You subtract X, you go to the left. Now, this seems unintuitive. Maybe it is, but it's the way every 2D game engine thing does it. Going down is positive Y. All right? So that means going up, you want to subtract from Y to get back to 0 up here. Okay. So Y equals Y minus speed to go up, and Y equals Y plus speed to go down. Hey, we got our circle moving around. All right? And we can go off the edge of the screen here. Do we want to fix that? I think that makes sense. Let's make R smaller. Let's just do 4. Just a little guy. Let's format this a little bit. clean this up a little bit, just make it take up a little less room. Now, we could prevent the player from moving before they move, but sometimes it's easier to let them move and then see if they've done something we don't want and bring them back a little bit. And we can use a little bit of math for that. Now, I know a lot of people get kind of iffy about math, and you do wind up using some math and programming, but it's usually pretty basic arithmetic. There's like a couple things that might get a little hairy for you, but like once you get them down, you realize you use them over and over, and you get used to it. Okay. So we let the player move however they want, but then we want to just like yank them back into if they get off the screen. So what we can do is we can do x equals mid x comma 0 128. Okay, y equals mid y comma 0 comma 128. All right, what's mid? Mid is a function. It takes in, I think, like any number of values. Really, hold on. Let me see. Let's ask Pico-8. Help mid. This is documentation on 3 similar functions. There's max, min, and mid. And the one we're looking at here is mid. And it takes in 3 values. Give the maximum, minimum of 2 values, or the middle of 3 values. Missing arguments are treated as 0. Interesting. So what it's going to do is it takes in 3 values. And it says which one of these is the middlest value. And it gives you that value back. So if x is between 0 and 128, it'll give you back whatever x was. If x is less than 0, right, then 0 is suddenly the middlest number. It'll give you 0 back. If x is greater than 128, then suddenly 128 is the middlest value, and it'll give you 128 back. So it's basically locking x, since we're setting x to be the mid of these 3 values. It's locking x between 0 and 128. And we're doing the same for y. Y is the middlest value, y 0, 128. Run it. And yeah, now we're stuck. Now, why can we go half off the screen? Right? That's not really what we want. Well, remember that x and y position is the middle of our circle. And the radius tells us this distance, right? And so when we move the x and the y like that, well, half our circle is off the screen. So we can work with that. Instead of 0, we can do r, right? And instead of 128, we can do 128 minus r. Hey, actually, 127. Because 128, the math gets a little funky in your brain, at least mine. It's 128 pixels across, but if it starts on 0, the 128th pixel is gonna be off the screen. It's funky. All right. Sometimes you just got to do a little trial and error with that. But we achieved our goal. We're locked on the screen there. So yeah, that's a pretty good start. We saw how things get drawn to the screen. We saw the magic trick that makes the player believe that they're controlling things and that there's real objects moving around. We learned how to set up a program with named variables and data in the variables. We saw how to get player input and change those variables, write our own instructions. We saw how to fake our way into making it seem like there are walls just with a little math. And we saw how to draw things to the screen and trick the player into thinking stuff's happening. And we can experiment. We can see the limits. We can see what's really going on behind the screens. We can see the tricks, right? And it's not too much more to make this seem like it's a little guy. You know what? Let's just jump in. I'm going to show you something, all right? See these little icons up here, right? We've been in the code editor the whole time. Let's add one more tool to our toolbox. The sprite editor. All right, there's a lot here. You can play with it. It's a lot of fun. We've got a sprite sheet. We're going to focus on this one right here, sprite number 1. Let's just draw a little guy, all right? We can just do it like this. You can right-click to eyedropper a color. These are the 16 Pico-8 colors. You can just do it like this. Let's see. You can fill. Yeah. You can give him a little face here. All right. Now, if we want to draw him, instead of circle, do SPR for sprite. That was sprite number 1. And we've got the X and Y. Boom. We've got our little guy. All right. And the sprite draws a little differently because it doesn't draw from the center. It draws from the upper left-hand corner. So we got to change this real quick. We'll do, instead of R, we'll do size equals 8. That's the size of sprites. Size. All right. How's that look? I think there's 1 pixel. Yeah, there we go. So sprite drawing's a little different. But now we've got a little guy. All right, cool. I think that's all for right now. I feel like that was kind of a lot. Hopefully we can do this again. Have fun. Draw some little guys. Play with some code. Check out some other stuff. Play with this cheat sheet. Type help. Learn about stuff. Pico-8. It's fun. I'll catch you all later.